I'm Harika. I'm studying BTech first year at SRIT College in Anantapur. I belong to CSM branch. Now I'm going to explain about the topic called separation of liquid mixtures. This is the topic called separation of liquid mixtures. There are various methods to separate liquid mixtures like simple distillation, separation of liquids, immiscible liquids, miscible liquids, fractional distillation, liquefying the air, chromatography, separation of a mixture, sedimentation and decantation. Let us see about filtration process. Filtration is the method of separating an insoluble solid from a liquid. A substance which does not dissolve in a solvent is called insoluble substance. Example for filtration is mixture of sand and water. Sand can be defined as a solid residue which stays behind in the filter paper, and water can be considered as filtrate. This figure shows filtration process in which glass funnel, a beaker, filter paper are used. When the mixture of sand and water is poured into this glass funnel, because of this filter paper, the sand particles, which is a solid residue, remains as it is in the funnel, and the water, which is considered as a filtrate, is which passes through this glass funnel and enters into the beaker. In this way, the water, which is a filtrate, is purified. Evaporation is used to separate a soluble solid from a liquid. This diagram would show a beaker with salt and water solution. It is heated. When this is heated, the water would vaporize while the salt particles would remain at the bottom of the beaker. How this process takes place? First, we need to heat the mixture. When we heat the mixture, the salt and water solution is heated. The water, which is a solvent, turns into gas when it is heated, and the water, which is in water vapor state, rises up. The salt, which is being a non-volatile solid, does not evaporate and remains behind as a solid residue in the beaker. Sand and water mixture is not suitable for separation like technique like evaporation. Sand is an insoluble solid. It does not dissolve in water. So we should use filtration process to separate sand and water mixture, and we should not use evaporation technique for separating sand and water mixture. Now let us see about separating mixtures of liquids. Mixtures of liquids can be separated according to their properties. The technique used depends on whether the liquids dissolve in each other and so are miscible or if they are immiscible. These are the different types of separating techniques like simple distillation, fractional distillation, separating funnel, centrifugation, sedimentation, decantation, and chromatography. Now let us see about simple distillation. Simple distillation is a method for separating a liquid from a solution containing dissolved non-volatile solids, or for separating two liquids with large difference in boiling points. At least the difference must be 25 degrees Celsius. The process, which involves the heating of a mixture to vaporize the more volatile component and then cooling the vapor to condense it back into a purified liquid. This is called distillate. This figure shows different kinds of components like round bottom conical flask and condenser, beaker, water outlet and inlet. We shall have a look at the process of simple distillation. The separation process occurs in three main steps like vaporization, condensation, collection. Let us see about vaporization. The liquid mixture in the round bottom flask is heated. The component with lower boiling point evaporates first, leaving the non-volatile components or higher boiling points liquids behind. When this liquid mixture which is present in this round bottom flask is heated, then the lower boiling point mixture is heated up and the higher boiling point component will be stayed in there and remained in the same round bottom flask, and the component which has low boiling point gets evaporated and it is passed through the condenser. Let us see what happens in this condensation process. The hot vapor which travels through the condenser is in contact with the cold outer surface. Because of this cold outer surface, it cools the vapor and this causes to change its state back into the liquid. When the component of which has low boiling point is passed through the condenser, it is cooled because of the cold outer surface, and because of this condensation it changes its phase from gaseous phase to liquid phase. And let us see the third step, that is collection. The condensed purified liquid drips into the receiving flask, effectively separating it from the original mixture. Now after the condensation process, when it changes its phase from gaseous phase to liquid phase, this liquid is dropped into the beaker and it is collected as distillate. Now let us see about separating funnel. Separating funnel is also known as separation funnel. Separating funnel is a piece of laboratory glassware which is used in liquid-liquid extractions to separate the components of the mixture into two immiscible solvent phases or of different densities. Typically, one of the phases will be aqueous and the other will be a lipophilic organic solvent such as ether, MTBE, chloroform or ethyl acetate. All of these solvents form a clear separation solution between the two liquids. The more dense liquid, typically the aqueous phase, unless the organic phase is hallucinated, sinks to the bottom of the funnel and can be drained out through a wall away from the less dense liquid, which remains in the separating funnel. And now let us see about fractional distillation. Fractional distillation separates a mixture of liquids with similar boiling points using a fractionating column. This fractional distillation process is applicable to the only liquids whose boiling points are similar, and fractionating column is used to separate the liquids. The mixture is heated, vaporizes, and the vapor rises up the column, which has a temperature gradient from hot at the bottom to cool at the top. This is called fractionating column, which is hot at the bottom and cool at the top. The vapor condenses and re-evaporates repeatedly on trays or packing material, becoming progressively enriched in the more volatile components. As it moves up, the components with the lowest boiling points are collected as gases or liquids, and while at higher boiling point, liquids like condense and are collected lower down. And this fractional distillation is also used to extract the crude oil. This crude oil storage is sent into this steam boiler, then from this it goes into the distillation tower. From this it moves into the cracking unit and also hydro treater. Through this crude oil is it we can extract many kinds of products like petroleum gas, naphthalene, paraffin, diesel, fuel oil, lubricating oil, etc. Crude oil means is nothing but a mixture of hydrocarbons that exists in liquid phase in natural underground reservoirs and maintains at atmospheric pressure after passing through the surface separating facilities. Next we shall see about the applications of fractional distillation. Oil refineries. The most common application is the fractional distillation of crude oil into various fuels and products like gasoline, diesel, and kerosene. Chemical industries. It is used to separate and purify mixtures of miscible liquids in various chemical processes. Air separation. It can be used to separate gases like nitrogen and oxygen from liquefied air. Now let us see about sedimentation and decantation. Sedimentation is the process of separating insoluble solid particles that are heavier than a liquid by allowing them to settle at the bottom of a container under the force of gravity. Decantation is the process of separating a liquid from a solid or from a second immiscible liquid by carefully pouring off the top layer. Now let us see about centrifugation. Centrifugation is a separation technique that uses centrifugal force to separate components of a mixture based on their density, size, and shape. By spinning the sample at high speeds, the denser particles are forced to the bottom of the container while lighter particles remain at the top, a process that is much faster than gravity based separation. This is widely used in labs for separating blood and in industries for products like milk and oils. Thank you.